let's continue with example 5. We're using the elimination method. Here in this example, we're in standard form, everything's all lined up. If you look at your coefficients, you have 5, 3, 4, and 6. None of them match and none of them are opposite signs. So you have a couple decisions to make on this one. The first thing you need to do is pick X or Y to eliminate. Sometimes one is a little easier to work with for elimination than the other, but it honestly doesn't matter. You just get to pick X or Y to eliminate. So I like even numbers, so I'm going to choose to eliminate Y. It's just total preference which one looks easier to you. Then your decision is to pick 1 to be negative. So if they're both positive, your job is just to pick one that you want to be negative. I'm going to pick the top equation because that constant is negative, and if I multiply everything by negative, it will become positive. So those are just choices you have to make. Which variable do you want to eliminate, and which equation do you want to be negative? Once we make that decision, we're going to have to multiply both equations by something to make those coefficients match with opposite signs. It's again kind of like common denominators. So if I have 4 and 6, I know I can multiply the top equation by 3 and then the bottom equation by 2, and they'll both become 12. So it's least common multiple, very similar to least common denominator. So my least common multiple is 12. I'm going to make them both 12. You could also use 24 and multiply each one by the other. Again, like common denominators, you just need these numbers to match. And then we have to pick which equation we want to be negative. I'm going to pick the top, so I'm going to make that 3 a negative 3. What that's going to do is switch that sign to negative like I need it to be. So now every term in the top equation multiplies by negative 3, and every term in the bottom equation multiplies by 2. So that's a lot of work there trying to get those coefficients to match. I'm going to kind of block this off so I don't lose it. Then you're going to multiply through, and we talked about writing the equations to the side so they don't unstack. So this is going to become negative 15x minus 12y equals, and then let's see, negative 3, whoops, negative 3 times negative 14 is positive 42. And then again, we're going to multiply the bottom everybody by 2, so it's going to be 6x plus 12y equals 12. So we multiply everybody through. We make sure we have those matching coefficients with opposite signs. Now we're going to stack and add. That's going to give me negative 9x. Those are going to eliminate. Equals 54. Divide by negative 9. And we get x equals negative 6. There's one answer. Then we'll pick one of the two original equations to plug back into. I'm going to pick the bottom original equation. You can use your new equations, but those numbers are bigger, which makes them a little more challenging to work with. So I'm going to pick 3x plus 6y equals 6. And I'm going to plug in my negative 6. So 3 times negative 6 plus 6y equals 6. That's negative 18 plus 6y equals 6. Then I'm going to add 18 to both sides. Eliminates that. 6y equals 6 plus 18 is 24. Divide by 6 and I get y equals 4. So now I have both of my answers, and I state my solution as negative 6, 4. If you feel comfortable with that, go ahead and try example 6. Again, you're going to have to make some decisions. Which variable do you want to eliminate, and which equation do you want to make negative? So pick your own, pause the video, pick it yourself, and then work the problem. Even if you've chosen differently than I have, you should still get the same solution. So pause the video and try example 6. Alright, on example 6, I notice that these coefficients are both negative, and these coefficients, one is negative and one is positive. So that part of the job is already done. So I'm going to choose to eliminate the y variables. I'm going to multiply the top equation by 9 and the bottom equation by 8. I don't need to throw a negative on either one of those because they already have opposite signs. So you just have to do what you need to make them have the same integer with opposite signs. I'm going to write my equations to the side. That's going to be negative 63x minus 72y equals 81. This will be negative 32x plus 72y equals, let's see, 22 times 8 gives me a negative 176. So the entire equation gets multiplied. Now we're ready to stack and add. That's going to give me negative 95x. These are going to cancel. And then if I do 81 plus negative 176, that gives me negative 95. Divide both sides by the coefficient on x. And that will give me a positive 1. A very small number for very big numbers to work with. Then we'll plug back in to one of the original equations. I'm going to use the top one. We have negative 7 times 1 minus 8y equals 9. So it's going to be negative 7 minus 8y equals 9. Add 7 to both sides. Bring it over here where I have some more space. We should get negative 8y equals 16. Divide both sides by negative 8, and y equals negative 2. So my solution would be 1, negative 2. So in your elimination, if none of the coefficients match, you just make these two decisions based on what looks easiest to you. Pick x or y to eliminate based on their coefficients, and pick one of them to be negative if necessary. Otherwise, make it easier on yourself. If they already have opposite signs, pick that variable. Now we're going to look at some applications using the elimination method. These are generally easier to set up and therefore easier to solve. You'll find these application problems a little bit less stressful. So example 1 says find two numbers whose sum is 37 and whose difference is 21. So two numbers, we can just use x and y. So a sum of 37 and a difference of 21. Nice and simple. If you add them together, you should get 37. If you subtract them, you should get 21. In this case, because x and y are unknown, it doesn't matter which one you put first, since we just arbitrarily chose x and y. If you look at how these are set up, they're already ready for elimination. Notice the coefficients on y are the same with opposite signs, so we can stack and add right away. Remember, this is 1x plus 1x, which is 2x. Positive y and negative y eliminate, and if we add those together, we get 58. Divide everybody by 2, and you should get x equals 29. And we'll plug in that 29. I like adding, so I'm going to choose the top equation. 29 plus y equals 37, and then subtract 29, and y equals 8. So the way these answers will state is just the two numbers are, and it doesn't matter which order you state them in, 29 and 8. So instead of writing an ordered pair for these, you just kind of state your answer as a general statement. Go ahead and pause the video and try example 2. It says a first number plus twice the second number is 8, and twice the first number plus the second is 25. What are the numbers? So pause the video and give example 2 a try. So if we have a first number plus twice a second, you get 8. Twice the first number plus the second is 25. So again, I just use x and y. You can use whatever letters you want. Keep it simple. X and y are generally the best, just so that they don't get mixed up. Alright, so everything's pretty fair here. They're all positive. You can just choose. I'm going to choose to eliminate the x's, and I'm going to make the top equation negative. Oops, so I'm going to multiply by just negative 2, not negative 2x. If I multiply everybody by negative 2, that gives me negative 2x minus 4y equals negative 16. Then we have 2x plus y equals 25. Now we're ready to stack and add. Oops, let me change to a better color here. We stack those and add them together. We get negative 3y equals 9. Divide by negative 3. So one of our numbers is negative 3. Then we'll plug that into either equation. I'm going to plug it into the top equation. X plus 2 times negative 3 equals 8. So that's x. That's going to be minus 6 equals 8. If I add 6 to both sides, I get x equals 14. And again, here it doesn't matter which one's which. You would just state the two numbers are in either order, 14 and negative 3. It doesn't matter which way they go for these types of word problems. Alright, moving right along to example 3. These are pretty common elimination questions. You might have seen them. If you're recently out of high school, you might have seen questions like this. They're very popular. It says the price for theater tickets for 4 adults and 2 children is $374. The price for 2 adults and 3 children is $285. What is the price for each adult and child ticket? So here we need two variables, one for adult and one for children. Instead of using x and y, I'm going to use a for adult and c for children, just so I can keep them straight at the end. You can again pick whatever letters you want, but a and c kind of makes sense. So we have 4a plus 2c equals 374, and then 2a plus 3c equals 285. So they're already set up for the elimination method. All the coefficients are positive. So let's see, if we have 4 and 2, we can make those match pretty easily. 2 and 3, it would take some more work. So in that bottom equation, if we multiply everybody by 2, and then make that a negative 2, that will give us the opposite numbers we need to eliminate. Oops, I didn't mean to draw the line, I meant to draw the arrows. So the first equation stays the same, 4a plus 2c equals 374. The second one we're going to do negative 4a minus 6c, and then we're going to do 285 times negative 2, which is negative 570. Make sure your negative doesn't run into your equal sign like mine does sometimes. Then we will stack and add. The a's eliminate. We have negative 4c, and then we're going to do 374 plus negative 570, which is negative 196. Divide both sides by negative 4. Let's divide that by negative 4. That's going to give us 49. These must be like going to the theater, like a live show, not like the movie theater. So the child ticket is $49. Now we're going to plug that into either one of the original equations. I'm going to use the top one. So 4a plus 2 times 49 equals 374. So 4a plus, that would be 98, equals 374. Move the 98. So 4a equals, let's see, 374 minus 98, 276. Divide both sides by 4. And we get $69. So again, you'll state your answer as kind of a statement. And it doesn't matter what letters you use, it's just going to ask you for the adult price, and then it will ask you for the child price separately. It doesn't matter which order you solve them in or which order you state them in, just make sure you keep which one's straight between adult or child. Go ahead and try example 4 on your own, pause the video and give it a try, and then play the video back to see how you did. Example 4 says admission for the baseball game for 3 adults and 3 children is $75, while the price for 2 adults and 4 children is $62. What is the cost for each adult and child ticket? So again, very similar to example 3. I'm going to use A for adult and C for children. So we have 3 adults and 3 children, 75. 2 adults and 4 children is 62. Trying to solve for A and C. Let me think. We've got 3 and 2 and 3 and 4. It doesn't really matter which one you use. Smaller numbers would be eliminating the A's. So I'm going to choose, and this is totally my choice, to choose to eliminate the A's. And I'm going to make the top one negative. But that's totally arbitrary. You can pick top or bottom, and you can choose to eliminate A's or C's. It doesn't matter. In the end, we'll get the same answer. Alright, so that's going to give us negative 6A minus 6C equals negative 150. It's going to give us positive 6A plus 12C. And 62 times 3 is 186. And stack and add, so 6C equals, that's going to be 36. Divide by 6, and C is 6, so $6 for children. Then we'll plug that in to get the other answer. I'm going to plug it into the bottom equation. 2A plus 4C equals 62. Now that I know C is 6, so that's 2A plus 24 equals 62. Subtract 24. So, whoops. 2A equals 62 minus 24 is 38. Divide both sides by 2, and you should get A as 19. And so you'll have the adult ticket is $19, and the child ticket is $6. Alright, and that is using elimination for application problems.